Alright, this is 6.1 part 3. We are talking about the compound interest formula. So this is the compound interest formula right here, where P is the starting amount, R is the rate, N is the number of compounding periods in 1 year, and T is measured in years. So let's look at this right here. An initial investment of 280 earns interest for 5 years in an account that earns 16% interest, compounded quarterly. Find the amount of money in the account at the end of a 5-year period, rounded 2 decimal places. Okay, so the amount that you start with, which is P, is 280. We are going to have this in there for 5 years at 16% interest, so that'd be 0.16. You have to get it out of the percentage. And well, how many times did it compound? Well, quarterly, so that would be 4. Okay, so after 5 years, so 280, 1 plus 0.16 over 4 raised to 5 times 4. That's supposed to be a 5, looks more like an S. There we go. Okay, so this is going to be 1 plus 0.16 over 4 raised to 20. Okay, so we have, let's clear this out, 0.16 divided by 4. I'm going to go ahead and add the 1. So 1.04. 1.04 raised to 20. Okay, so raised to 20. I'm going to go ahead and multiply it times the 280. So we get 613.514. Okay, that 4 is not going to change that 1, so it's 613.51. And this right here would be our final answer. Now let's go to this one right here. Okay, so we're trying to evaluate the compound interest formula, and it gives us everything that we need. All we have to do is plug these numbers in here. So we've got, okay, P is equal to, actually we'll just go ahead and plug this in since they give that to us. 7,249, 1 plus 0.15 over 4 raised to 4 times 3. Okay, so this is going to be 1 plus 0.15 over 4, and that will be 12. Okay, so we've got 15 over 4, so 0.15 divided by 4, and then plus 1. I'm going to go ahead and raise that to 12, and then multiply it times 7,249. So that gives me, we'll round to 2 places since it's talking about money. 11,275.488. Okay, that 8 is going to make that other 8 go up to 9. So 11,275.49. 11,275.49. And that is our evaluation of this compound interest formula given these conditions right here. Now let's look at compounded continuously. Okay, so the formula for this one would be P times E raised to R times T. So P is the principal or the initial investment, R is the growth or interest rate, and T is the period or term of the investment. Okay, so what will be the amount in the account with initial principal of $11,208 if interest is compounded continuously at an annual rate of 2.56% for 9 years? Okay, so here RP is equal to 11,248. Now it says back here that R is the interest rate per unit time. So our annual rate is 2.56, so that's going to be, 0.0256. And all I'm doing is I'm taking this and I'm dividing it by 100, and that's how I'm getting this number right here. So you would take 2.56 divided by 100, and that's how I'm getting the 0.0256. Okay, and then T is 9. So for 9 years, T is a period or term of the investment. Okay, so after 9 years, we're going to have 11,248, and then E raised to R times T, so 0.0256 times 9. Okay, so I'm going to start with E, and I'm going to raise it to, and I'm going to open parentheses, 0.0256 times 9, close parentheses, hit the equal, and then multiply that times 11,248. So we get 14,162.346. Now that 6 is going to change that 9, and since it's 9, it's going to change from 39 to 40. Okay, so our answer here is 14,162.40. So that's how much we would get after 9 years with an interest rate of 2.56, compounded continuously when we invest 11,248. This is how much we would have in the account after the 9 years. Okay, well, what will be the amount in the account with the initial principal of 1,785 if the interest is compounded continuously at an annual rate of 7.02 for 5 years, rounded to decimal places? So P is equal to 1,785. The time is 5 years. R is 0.0702. And really, you could take this and divide by 100. Or what I do is I just move it to decimal places. Okay, and then that's all we need, so we just plug it into our formula. So after 5 years, 1,785 times E raised to 5 times 0.0702. Okay, we're going to start with E, and we're going to raise it to, open parentheses for me, 0.0702 times 5, close parentheses, equals, times 1,785, and that should give us 2,535.769. Okay, that 9 will affect that 6, so that'll be 57. So our final answer for this one is 2,535.57. Now let's take a look at the last one. Suppose you have $2,983 to invest. Which investment yields the greater return over 5 years? 2.3 compounded continuously or 8.5 compounded quarterly? So we're going to have to set up two equations here. So if it is compounded continuously or if it's compounded quarterly, which one will give us the biggest return? Okay, so compounded quarterly. So both of them have a P of 2,983, and two of them have a time of 5. Now the rate for the compounded continuously would be 0.023. The rate over here would be 0.085. And here I also need n. Compounded quarterly, that means that's equal to 4. Okay, so after 5 years, this would be 2,983 raised to e, or times e, raised to 5 times 0.023. And we'll get an answer for this one. Over here, this will be 2,983 times 1 plus 0.085 divided by 4 raised to 4 times 5. Okay, I'm going to look at the compounded continuously first, so I'm going to have my e raised to, and let me clear everything out. Okay, so this will be e raised to 0.023 times 5, and I don't think I have the parentheses there, so e raised to, open parentheses, 0.023 times 5, close parentheses, times 2,983, and you get, so for that one we got 3,346.55 for that one. And we had an 8.548, so that 8's going to change that 4 to a 5. Okay, so we'll do this one right here. Okay, so we've got, and let me see if I can move this to where I can see what I'm doing. Not really. Okay, 4 times 5 is 20, so just make a note of that. So we're going to take 0.085 divided by 4, add the 1, raise that to 4 times 5, which is 20, and then multiply that times 2,983, and we get 4,542.496. That 6 is going to change that 9, so that means it's going to be 0.50. Okay, so we got 4,542.50. Okay, so which one gives us the greatest return? Well, that's going to be this one right here. That is compounded quarterly over those 5 years at an interest rate of 8.5%.